DVT, right, now we've got the problem in that because our FPGA isn't big enough to do the IFFT, we've had to do it in a PC, and the FEC comes before the IFFT, so that's got to be done in the PC as well. And I found that with the 2 megs anyway, when it's doing half rate FEC, the IFFT is using the most processing power. When you start increasing the constellation, 16, etc., and 64, it swaps around, and the interleaver and FEC starts to use more than the IFFT does. The I stands for inverse fast Fourier transform. Also, the USB 2 bandwidth is not really adequate for 8 megahertz, so it limits what we can do on that. I've had to take shortcuts, which means the signal's not as clean as it should be, and also for the 8K mode of DVB-T, the oscillators are the symbol rate generator on the board, which is derived from the 48 meg clock, which I use for the USB interface, is not adequate. There is a space on the board for an SI570 clock chip, and if you have one on your board, the software will recognize it and will use that in preference to the 48 meg clock. Whoops. Right, now, if the this is the unwanted sidebands that have appeared, and that's because the sample rate is not fast enough to the D to A converter. That's on 437. It's a 10 meg wide, so it's what, 2 megahertz of channel. New hardware. Well, Art's been working on a low power add-on amplifier for the board. I think he's just using multiple MMICs to produce the amplifier, and he hasn't decided whether he's going to do it as a kit, a fully assembled thing, or just a constructional article. It's sort of all up in the air. No, it's a broadband one. I'm not sure. I don't know the exact details, but I know he's had some stability problems with it, and so that's the only really ongoing thing that's at the moment. We thought of adding a receiver to the board, but it's just not worth doing. I mean, it's cheap to go and either use a set-top box or a USB dongle or something. Then we thought, well, let's do a new board. It wouldn't replace DATVExpress, it would be in addition to, sort of high-end board, and follows us just some ideas. I mean, nothing's concrete. Aims, it's got to fill a need. If people don't want it, there's no point doing it. We don't want to replicate what other people are doing. Finding out what other people are doing is quite difficult sometimes, because you only hear about it after you've started doing it, and they say, well, I'm doing that. And we want to make it as future-proof as possible. We want to make it expandable without buying extra stuff, which is very difficult to do, but it's... And the other problem is that when you start with a blank sheet of paper, you end up with designing an SDR, to do the receive and the transmit, and you think, well, if that's the case, why not just go and buy an SDR from, I don't know, a Myriad RF or one of the other SDRs that's available. So we thought, well, there's no point in doing that. We'd like to get other people involved, because there's an awful lot more to digital television than just the transmitters, and we'd like to have more software and doing all sorts of things. And of course the standalone operation, which is is something that people seem to want desperately. Yeah. Now, I looked at various ways of doing it, and on the HPSDR TeamSpeak audio, one of the guys on there, his company have been using these 230-pin MX-M3 modules, CPU modules, because they're multi-layer boards. You've got something that's guaranteed to work. You don't have to design it yourself, and it just plugs in. So I thought, well, that's a pretty good idea. This is just a basic overview, because Ken said, I'm a pictorial guy, I need a picture. I said, I'm not an artist, this will have to do. So basically, down the left side, you've got the interfaces, the CPU card will plug in, the FPGA similar to what we've already got, the RF modulator identical to what we've already got. Originally we were going to look at putting one of the Comtech modules in there, but Art said, well, why bother with that? Just put a USB socket in there and people can go buy a dongle for it, for whatever band or interest that they have. And the particular module we were looking at also has all sorts of other I/O on it. So, and it's even got a CCD interface. This is what a typical dongle, one of these boards looks like. This is a Tegra 3 processor from NVIDIA. It's only got 1 gig of memory on it. They do a 2 gig version, which is the one we were looking at. And it's got 200 odd I/O, but they're programmable. Each of the pins has about 3 uses. So depending on what you want to do, you can configure the I/O to do that, or it can be gigabit Ethernet or something. So you can fully customize this board to do whatever you want. You don't need to worry about the shortage of I/Os on things like the Raspberry Pi, and you can use the bits that you're not going to use as I/O, so it's quite flexible. Now the board, which looks like this. This shows you, you've got, he's added all the I/O the thing's got on it, RS-232, DVI I think that is, gigabit Ethernet, 4 USBs, they've got a OTP socket, some more I/O, and I can't quite see what those are, and there's some audio. This board actually has audio on it as well, and there's all the power supplies. You wouldn't actually, the end user wouldn't want one of these, but that would be what the new DATVExpress would look like. It would just be a carrier for this other board with the whatever the video capture chips and the RF and FPGA on it. I have to stress that these are just ideas at the moment, and having spoken to Jason, maybe they'll change. The Tegra 3, the 2 gig one, costs £104. The carrier board is 200 quid, but that's really for development. And they also do a video capture board based on that chip for 31 quid. I just threw that in there. We'd probably use a different chip if we were going to do it, something that's more suitable to our need. We haven't started looking yet for particular chips. Why do it this way? Well, as I said before, it reduces the risk for the CPU. We don't have to design a 12-layer board, and we've got something that the manufacturer guarantees will work. Everybody's using the same piece of, or the same hardware, therefore the same software, so we don't have dozens of people using different things and trying to get it to work on everything. Also, this will allow us to concurrently do the DATVExpress itself. It took 4 years because we couldn't really do much of the software until we'd done the hardware. With this, by using the manufacturer's carrier board, we can mock up a system to do the software on while the thing in there. It's got lots of connectivity. It's got USB 2, gigabit Ethernet. It's got a PCIe ×1. It's also got a PCIe ×4 interface on it. And as I was saying to discussing with Jason, some of the FPGAs have got PCIe interfaces on them in hardware, so you don't need to pay for license. And I mean, this is a nice word, heterogeneous computing. It just means sticking GPUs, CPUs, FPGAs, and all having them working together, doing the bit that they're best at. Again, we can specify a suitable video capture device so it works. You don't have to go on eBay and find some clapped out old Halpage card that's only available in somewhere or other that we've never seen, which is what's happened. It's got, oh, the laser's going. It would be network enabled. I've done some experiments actually on the Raspberry proof of concept with a wireless access point and a web server, and then the web server talks to the software that does the transmission, so that you can use your iPad or your mobile phone to control the thing if that's what you want. Hopefully, because it's Linux based, ARM, etc., you might be able to get some people that have been programming with Pis interested in helping. You never know. We're looking at a target price for around $700. That's unlikely to be the final price. But these are ideas. If people don't want this, or someone else comes up with a product, we're more than happy to step aside. I mean, we're just looking for work to do, because we've just about recovered our outlay on developing the DATVExpress, so the person that financed it's got all his money back. So we're now looking what to do next. Just so off the cuff, main station transceiver, mobile station transceiver, portable station transceiver, single board low power repeater. I mean, it's got all, it can either be digital or with your own application. I mean, it's a fully programmable platform, or would be, so it can do whatever you want it to do, or whoever. Sorry? Well, you could do, actually, because the FPGA and what have you, because I know Rob MDS has been playing around with chirp radar using the DATVExpress board, so that's quite interesting. Go on and have a look on his website. Right, back to Earth. Next release of DATVExpress, current will fix some bugs. We've been doing some testing with the Hides dongles, and we found an incompatibility between the two. And also, I haven't fully fixed this PCR problem yet, because I thought I'd fixed it. I've had nice test files, and they went through all the test software, and they looked perfect. It was only that I twigged that every now and again, when I put a stuff packet in there, it doesn't actually end up in the transport stream that's saved to file. So what was going out over the air wasn't exactly what I was testing. I've found that out now, so hopefully the next version will sort that. Right, the Debian releases, the installation files, because they've got to be stable, because people that have with very basic knowledge are using them, they also tend to be boring. They haven't got the latest features in them. That if you want the latest features, you need to clone the JIT repository and build the packages yourself, because there's all sorts of stuff in there that you can compile in and compile out and what have you. And the most difficult bit is setting up the Qt4 environment. Once you've done that, it's easy to build the stuff. Right, why haven't there been any recent releases? Well, I've suddenly got interested in diversity receivers, and so I've been trying to make a 4-channel diversity receiver. The original idea actually was for the fun cubes, so that you can actually, I looked at the price of rotators, elevation rotators, and I thought, bloody hell, this is expensive. Why not just have fixed antennas and rotate them electronically? And so, the idea was to be able to track every CubeSat there is with one receiver.
Satellites are banned. There's been too much talk about satellites.
Yeah, well, I mean, I'm just saying that was the original idea.
Oh, that's all right.
Then I thought...
Moved on to something much more interesting.
Yeah, well, then I thought, these A to D converters only work up to about 65 megahertz. That means I've got to put some RF in there. I'll have a play on HF first, see if I can get it to work on HF, and then I might think about doing it at 2 meters or 70 centimeters. And then finally, the ATV related bit is that if you've got this type of thing, you can do beam forming, you can point the beam at a particular station, or you can direct a null at an interferer. I was thinking that might help with ATV repeaters that are getting radar interference. When the powers that be fire up their radar, it would detect the radar and it would try and optimize out signals coming from that particular direction, because they're obviously point sources. So but the trouble is that to do the wide bandwidths of ATV, suddenly you've got lots of data floating about, and you need multiple receive channels. So the number of receive channels times the bits of data for a single channel, there's gigabits of data floating about. So whether it's practical to do it at the moment for ATV, I very much doubt it, but maybe in a couple of years' time. The technology is moving that fast. And that's it. Any questions? Yep.
You must have a great deal of difficulty keeping up with the latest and greatest hardware changes.
Oh yes. I mean,
you can't lock a design down because somebody pulls the rug out.
Yeah, I mean, the analog devices have been quite good. We have a relationship with them. I even had a phone call from them the other day, but they've said that their particular chips that we're using are not going to become obsolete in the foreseeable future. But it's the stuff coming from the Far East that goes obsolete overnight. The American stuff tends to last a bit longer. Happened with the PLL modulator on our board. The original one only covered L-band, and then they came out with a new chip that was basically pin for pin compatible, so we just put the new chip on the board and that was it, and suddenly we get 75 megs to 2.45 gigs. So I just want them to do one that goes further.
Yeah.
Any other questions before lunch?
The analog devices guy, he said to me, you know, when he found out what I was doing, he said, you know, we do a dual channel SDR transceiver that goes up to 6 gigs. I said, yes, I know, it's expensive. He said, funny you should say that. Our other customers have been saying exactly the same thing.
Okay, good. All right, well, let's thank Charles in the normal way and congratulations.
Thank you.
Okay, so that brings us to the end of the talks programme as such.